The topic of the fourth presentation is improving the design of a rotational viscometer for tribology, presented by Professor Evsin.
Hello, the participants and listeners. My name is Mark Evsin, and I PhD student in Petrograd, St. Petersburg Polytechnic University. Let me introduce you to the presentation. My presentation named Improving the Design of Rotational Viscometer for Turbology. As is known, in rotational viscometer, the test fluid is placed in the space between two auxiliary bodies and rotating relative to each other. The internal friction of the test fluid, called viscosity, would prevent this rotation. Thus, the measurement of fluid viscosity is reduced to measuring the moment of resistance to rotation at a no shear rate. In the real world, the measurement process is complicated by errors created by the non-ideality of various parts of viscometer. And in this paper, we consider the effect of friction and the bearings of measuring part of measurement accuracy. One of the options for solving the applied problem of increasing the accuracy of industrial rotational viscometer by reducing the error from internal friction in the device is presented. This is important for tribologic tips because in this area, these devices are operated in a variety of modes. An error from friction can give an incorrect idea about the behavior of the student's lubricating fluid. A simple method for determining the static moment of the friction has been developed for this. Using a load of no mass, a moment was applied to the measuring part of the device, deforming the precision elastic element of the device is screw spring by a curtain angle. In this case, the angle of equilibrium could vary within curtain limits. The difference between the min and the max values was taken as a static moment of friction. As can be seen from the graphs, rolling bearing not so good for this. Here is the first solution of this problem. Such bearing is a rule used for very lightly loaded systems such as watches. Therefore, it was interesting to consider the possibility of using this scheme for significantly more loaded system. The friction moment for this case depends on radius of the core and the truss bearing, as well as Young models of those components of the friction pair. To achieve maximum results, the core was made of high hardness bearing steel, and the truss bearing was made of synthetic technical corundum. Here is another possible scheme for solving the above problem. The idea here is that the device is always used strictly vertical position, so the upper stop is not required, and the radial forces is very small. The experimental results are shown in the graph. The axis show the moment applied to the measuring part, and the y-axis is the error generated by the moment of friction in the bearing of the device. Thus, at low values of Tokyo, classic rolling bearing introduced a significant measurement error. The design option presented by the letter is most preferred for use in devices of this type. The accuracy of the device is increased by more than 3% due to the reduction of friction in the bearing of the measuring part. That's all. Thank you for attention. Do you hear me?
Thank you. Any question? If there's no question, I have a question that I like to ask Professor Theory. Is it the no, evidence? Sorry. Which one? You mentioned three different types of bearing. Which one is the one that for the viscometer that is frequently used? And another question is that as far as I know that there's another alternative which is using gas bearing instead of contact solid bearing. So have you ever considered that? Thank you.
I hear you not very well. You ask which one is the best, yeah?
In that, which one is the one that currently the viscometer use most?
Excuse me, I don't hear you. Can you repeat your question?
Okay, no problem. You mentioned there are three different types of element bearing. One is rolling, and another one finger, another one is the core type, right?
Yeah.
And which one is the mainstream for the viscometer currently used?
Usually used rolling bearing. It's simple for use, but the result is not very good.
Okay. So another question is that for the viscometer, there is another application is to apply the gas bearing to the viscometer to reduce the shear force. So have you ever considered about that, or maybe you may compare the gas bearing friction with the types that currently you use? Thank you. Thank you for your presentation. Let's move on to the next one. Thank you.